VLSos here. This is a video lesson on E. E is a letter, a symbol that we've given to a very special number that comes up in mathematics. Let's begin by using the context of investing money. And imagine investing $1,000 at 5% for 3 years. We calculate how much money that we would have after that amount of time by taking the $1,000 and multiplying by 1 plus the interest rate as a decimal, 0.05, and then raise it to the third power. A calculator can help us with this. 1.05 to the third, then times 1,000, is $1,157.62. But banks don't often wait an entire year to apply interest. The word compounding means to apply interest in this case. And banks don't wait a year to do that. They often compound instantaneously or continuously, or they compound once per day. And so we could change our question just slightly to consider compounding more often than once per year. We could imagine investing the same amount of money at the same interest rate for the same amount of time, but what's changing is that we're going to imagine applying the interest daily. Or 365 times per time period of 1 year. And the way that it changes the equation, we still have the $1,000, and we're going to multiply by 1 plus, but what we have to do with the interest rate of 0.05 is we divide it by the number of times we're compounding. In this case, daily means 365 times per year, because that's that amount of days in a year. And then we raise to the time, but we also multiply by the number of times we're going to compound. And this changes how much money we have at the end of 3 years. A calculator can help us and show us that in this context, we'll have $1,161.82. So it pays, literally, to compound more often. We only get approximately $4 more by compounding once per day rather than once per year. But we can consider compounding more often than once per day. And we could literally take this to the limit and consider compounding an infinite number of times, or compounding at every instant. Would we have an infinite amount of money because we compounded an infinite number of times per time period? No, but we'll see why. First, let's consider the general equation for compound interest. In this case, we're going to consider investing a principal P at an interest rate R for T number of years, and compounded n times per time period T. The general equation is the amount of money will be equal to the principal times 1 plus the interest rate divided by the number of times we compound to the number of times we compound times time. And if we're interested in compounding as much as possible, quite literally an infinite number of times, then we would imagine n in this expression or this formula getting arbitrarily large. or going to infinity. And to understand why that isn't going to produce an infinite amount of money, even though our money grows the more times we compound, we have to understand the nature of the math in this equation that n is involved with. I'm going to define a function and isolate the part of the equation 1 plus 1 over n to the nth. So we have the same type of equation. We can consider principal, rate, and time all to be values of 1 so that we can just see what the effects of n have on this part of the equation. We could see that in a graphing form by graphing this function that I just defined, where n is the horizontal axis, and the vertical axis is the value of the function. We can see at an n value of 0, we're going to need an open dot to represent a value that doesn't exist at the function at 0 because we can't divide by 0. But as soon as n increases, we'll get values in this function. When n's value is 1, we have 1 plus 1 over 1, which is 2, and then to the 1 makes a function value of 2. We can draw the values of the function and graph it to look approximately like this. We can see that the values of this function level off. There is a horizontal line that represents a horizontal asymptote of this mathematics, meaning that as n gets larger and larger and larger, the values of this expression grow, but they never reach or surpass the value of this horizontal asymptote. So where is this horizontal asymptote? What value does this function approach but never reach or surpass? We can express it this way. As n gets arbitrarily large, the expression 1 plus 1 over n to the nth approaches this value e. And in fact, we can define the value e to be this expression as n goes to infinity. E has an approximate value of 2.618281, and it's irrational, so we can never write it down completely. This is a special number, and it's a constant. It's always the same value. It's special because, like pi, E crops up in science and mathematics in many applications. Some people are quite entranced by how often E becomes a part of natural science and the mathematics behind natural science. How does E apply to our money investment situation? Well, if this equation will calculate an amount of money that grows, and we literally allow n to go to infinity, then this equation, as n approaches infinity, can be replaced with another equation for instantaneous growth or continuous compounding. And that equation is the amount of money is equal to still the principal, but the 1 and the over n to the nth have been replaced with e, and then the exponent is the interest rate times time. This equation, m is equal to p times e to the rt, is called the continuous compounding growth. Let's finish by using it. We had the context of $1,000 being invested at 5% for 3 years. If we were to put that into a continuous compounding account, we would have 1,000 times e to the 0.05 t. And that is approximately equal to the nearest penny, $1,161.83. Notice that the more you compound, the more money you're going to make, or the more it's going to grow. If you compound once per year, you will have $1,157.62. If you compound 365 times a year, you're going to have a few dollars more. But if you compound an infinite number of times, which is many times more, obviously, than 365, you're only going to get 1 penny more per year. This exemplifies what we call diminishing returns. The more you compound, the more you get, but then also the less you get in addition.